In this video, we will see the further problems from exercise 6.7. Question number 4. Find the non-parametric form of vector equation and Cartesian equations of the plane passing through the point 1, minus 2, 4 and perpendicular to the plane x plus 2y minus 3z is equal to 11 and parallel to the line given by this equation. Now, we can define our point here as a point A. So let A be 1, minus 2, 4 and let this be a point on the plane. This is our required plane. Then we have that this plane is perpendicular to the plane x plus 2y minus 3z is equal to 11. So this is this plane, which is x plus 2y minus 3z is equal to 11. Then it's parallel to the line given by this. So our direction ratios of this line will be 3, minus 1 and 1. So we can define a vector C as 3i cap minus j cap plus k cap. So this is parallel to our plane. Now, since this is perpendicular, the plane is perpendicular to this plane, the normal to this can be defined as L, M, N, which are the coefficients of L, X, Y, and Z. So we can define that as our vector B. So vector B, we'll start with vector A. Vector A is our position vector for point A. So that is equal to I cap minus 2j cap plus 4k cap. Then we have our vector B, which is going to be the perpendicular to this plane, which is will be defined as I cap plus 2j cap minus 3k cap. That's our LMN here. Then our vector C, which is parallel, is defined as 3i cap minus j cap plus k cap. Now the parametric, actually we need the non-parametric. So the non-parametric form of vector equation is given by R minus A vector dot product with B cross product with C is equal to 0. So we need to find our B cross product with C first. So B cross product with C will be equal to the determinant I cap, j cap, k cap, and our coefficients of B1, B2, B3 will be 1, 2, minus 3, and then similarly for C it will be 3, minus 1 and 1. It's equal to minus I cap, and it's 1 plus 9, so that will be minus 10 j cap, and k cap coefficients will be minus 1 and minus 6, so it will be minus 7 k cap. So that's our B cross product with C. Therefore, substituting the value here onto this, you get R minus A vector dot product with minus I cap minus 10 j cap minus 7 k cap is equal to 0. Further rearranging this, we can rewrite this as R cap dot product with minus I cap minus 10 j cap minus 7 k cap is equal to vector A, which is defined as I minus I cap minus 2j cap plus 4k cap dot product with B cross C, which will be minus I cap minus 10j cap minus 7k cap. So this further can be simplified as minus into minus 1, minus 1, then minus 2 into, so plus 20 and minus 28. That's equal to minus 9. So our non-parametric form of the equation is or vector dot product with I cap minus 10j cap minus 7k cap is equal to minus 9. Further, the Cartesian form or Cartesian equation is x I cap plus y j cap plus z k cap dot product with minus I cap minus 10j cap minus 7k cap is equal to minus 9. Further simplifying this, we get minus x minus 10y minus 7z is equal to minus 9, which can be rearranged as x plus 10y plus 7z is equal to 9. So that's our Cartesian equation. Question number 5. Find the parametric form of vector equation and Cartesian equations of the plane containing the line r is equal to I cap minus j cap plus 3k cap plus t times 2 I cap minus j cap plus 4k cap and perpendicular to the plane or vector dot product with I cap plus 2 j cap plus k cap is equal to 8. Since this line contains or is contained in the plane, so the point which would be our point A or this position vector here is on the plane, so is equal to I cap minus j cap plus k cap is a point on the plane, and our 2I cap minus j cap plus 4 cap will be parallel to this plane. So B vector is equal to 2I cap minus j cap plus 4k cap is parallel to the plane, and the plane is perpendicular to this plane given by this equation. That means it will be parallel to this vector here. So it is again C vector, which is equal to I cap plus 2j cap plus k cap is parallel to the plane. Therefore, the parametric form of equation of vector equation is r vector is equal to a vector plus sb vector plus tc vector, where our s and t are scalar quantities and belong to R. So rearranging with the values of a vector, b vector and c vector, R vector is equal to I cap minus j cap plus 3k cap plus s into 2I cap minus j cap plus 4k cap plus t into I cap plus 2j cap plus k cap. So that's our parametric form of the vector equation. Now for the Cartesian equation, it's given by the determinant x minus x1, y minus y1, z minus z1, b1, b2, b3, and c1, c2, c3. Substituting the values x1, y1 and z1 are the coefficients of the vector A, I cap, j cap and k cap. So we have x minus 1, y plus 1, z minus 3. Then you have b1, b2, b3 as 2, minus 1 and 4, and c1, c2, c3 as 1, 2 and 1. So further simplifying this, you get x minus 1 multiplied by minus 1 minus 8 minus y plus 1 into 2 minus 4 and plus z minus 3 into 4 plus 1, and this is actually equal to 0. That's our Cartesian equation. So this is equal to 0. So further we can simplify this as, this is minus 9, so minus 9x plus 9, and this is minus 2, so plus 2y and plus 2. Then you have 5z plus 5z and minus 15 is equal to 0. Simplifying this, we can rewrite this as 9x minus 2y minus 5z, 9 plus 4 minus 15 will be, 9 plus 2, which is 11, so it's minus 4 will become plus 4. Plus 4 is equal to 0. So that's our Cartesian equation.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.